Now we're going to look at the addition properties when you are working with a set of integers. And you're going to notice that you've seen most of these properties before. All the same properties that worked with whole numbers, they still hold up when we're dealing with integers. So a lot of these properties are the same, so I'll just review them very quickly. We have the closure property, which tells you if you add two integers, you are guaranteed to also get an integer. So the set is nice and closed. The commutative property, remember that's the one where the numbers move, they change order. So a plus b is the same thing as b plus a. The associative property is the one where the order of the numbers doesn't change, but just the parentheses and who's associated changes. The identity property, what number could you add to retain the original number's identity? Well, you could add nothing, and then the original number won't change. So a plus 0 is the same thing as 0 plus a, and those are all a. 0 is called the additive identity. Then we have the additive inverse property, which is basically another way to say opposite. So for every integer a, there exists a unique integer, negative a, such that a plus negative a is 0. Well, if you take a number and you add its opposite, you get 0. They're just calling the opposite the additive inverse. That's the fancy name for it, but I'll put here it's also called the opposite. A couple other properties. The opposite of a negative number would be a positive number. This is why two negatives make a positive, because the opposite of a negative is a positive. So that's a property that holds. If you have a negative number plus another negative number, why do you want to write the negative twice? You could just write it once. So you see what they did is they factored that negative out to the front, and they just put a plus b here. So meaning this negative is going to get applied to everybody inside here. It's going to get applied to the a and also the b. So this is just, they say the same thing. It's just you have to write the negative twice on the left, but you only have to write it once if you write it like it is on the right. But they say the same thing. And then the last property is if a is equal to b, then a plus c is going to equal b plus c. And so this is kind of getting into, it's hinting at solving equations, where as long as you do the same thing to both sides, you will retain the equality. So as long as you're adding the same amount to both sides, then the two sides will still be equal. And then there's just a couple examples here. It says find the additive inverse, or the opposite of each expression. So we're going to find the opposite of this expression. Well, opposite mainly means just change the sign. So the opposite, if this is negative x plus 1, the opposite would just be positive x plus 1. You just change the sign. So that would be the opposite. Notice these are not equal to each other. We're finding the opposite. How about this one? The opposite is, okay, this one looks like this number 2. If you put the 4 where the a is and the 5 where the b is. So that is actually this amount, if you add it, just so we are clear, that amount is negative 9. So what is the opposite? It's 9. But the opposite would be 4, change the sign, 5, change the sign, which would be 9. But I don't know if they're looking for that as an answer or this as an answer. They're the same thing. But to negate this or find the opposite, you change the signs. So it makes what is negative 9 turn into positive 9. And then the same thing here, if we want to find the opposite is going to be, we need to change the signs. So instead of x, we're going to have negative x, and plus, instead of a negative 2, it's going to be a positive 2. So you see how the signs just changed, and that makes it the opposite, or the additive inverse.